Yeah, it's great to continue from what Stefan told us about the Brownfield, and it's been actually a pleasure to watch the whole show this week, and I think it's the best OPC day so far. So I'm happy to be part of that, and there's been already like a lot of talk about OPC UA, what it is, and how much more it is than just a protocol, but the practice is that the Brownfield is still like a little bit behind what the specifications of OPC UA enable, and we want to talk about the alternatives, how you can move on with the Brownfield installations. So I'm Jouni Aro, I'm the CTO here at ProsysOPC, and I prepared this presentation together with my colleagues Ismo Lesinski, who's the head of development, especially for this kind of Brownfield solution that we're presenting, and Pyry Grönholm, who's the CEO running the company. But all of us have been working a long time with OPC UA. Me over 25 years here as a CTO, starting with the classic and seeing the progress. And I think the guys at the OPC Foundation, they've been doing a fantastic job in improving the specifications. It was a pleasure to hear again about Jim Luth talking about the improvements in 105.04 that are upcoming. So there's a constant stream of improvements. But the challenge is that how can we like take advantage of all those improvements? So that's what I want to talk about today. So first, a small slide about Prosys, because not everybody knows. We were already founded 1995, so almost 30 years old. And we are located here in Espoo, Finland. And we've been specialized in developing software for the automation industry since the beginning, and OPC has been our specialty also over 25 years. And we work together with the OPC Foundation to provide solutions as well. And we'll be also hosting the OPC Day Finland here. This year will be the 20th event. But we've provided solutions mainly for the developers, but we also want to help the end users to really take advantage of all the OPC UA features. So the state of the art in OT still today mostly is that it's full of all kinds of legacy communication. There are mostly point-to-point connections, proprietary data models that are being used. There's no security in general and no access control applied. We all know this, and it's a reality. And there's nothing kind of wrong about it, because the OT is not moving forward to the latest technology as the technology appears. It tries to keep the production running, and you don't touch a working system unless you really have to. But of course, there are more and more demands to move more information out of the OT to the IT, and this creates the real challenge. And OPC UA should help in dealing with all of this, but does it? Well, what is OPC UA then? Many people say that it's just too much and it's not very clear what it is. There are hundreds of pages of specifications defined, but in the end, it's not very complicated. OPC UA defines how you exchange data between different systems, and it's mainly measurement data, parameters, and things like that. So we have base services to read and write variables, monitor data changes. And then we have the advanced features already, like monitoring events, making method calls from one system to another, doing history reads. and even history updates in the exotic case. But this is basically what OPC UA defines. It's not more complicated than this. On top of this, though, it can also enable a full language of information modeling, and the base specifications already continue to the basic data access definitions, alarms and conditions, programs, models. And then we have the additional models, devices, for machinery, and then all those companion specifications that are already over 100 of them, which are created with the domain specialists. And this is the real power of OPC UA that will change the world in the end. At the same time, it takes care of security in the communication with all these aspects of confidentiality, integrity, availability, but also authentication, access control, and auditing, which are very, very important in the end. And it uses different transport protocols to really make the communication happen. But as Stefan says, OPC UA is not just a protocol, it's the framework that enables all of these things over different communication protocols. And there is a reason for the different communication protocols. We heard about those already this week. But of course, it's a challenge for different systems if they need to implement all of these models, that when and how can they really do that. But the first concept that helps already, especially dealing with the secure communication, that OPC UA also defines, is the concept of aggregation server. And we actually have already a lot of products that are doing this in the market. They are mostly doing the protocol conversions, but they're also acting as a single point of access. And typically, you can already use these products to place this kind of aggregation server in between the IT and the OT network, put it in a DMZ area, which ensures that there's no direct connection from the IT to the OT. And this is a great place also to apply all kinds of security measures independent of the actual security measures provided by the devices in the OT network. So the OPC UA security is defined in different OPC UA specification parts, 2, 6, 12, 18. They define different concepts, how to deal with the confidentiality and integrity by message signing and encryption in the communication protocols or the transport protocols, defines how to authenticate applications, how to authenticate users. The latest specifications also define access control with a role-based approach. And we have a way to make the communication happen reversely so that you don't need to open extra channels through the firewall. Rather, the connection is open from the OT to the IT. And now the question is that this easily becomes like a challenge if you apply the security over all the components in the OT and also maybe in the IT. Where can you manage all of this? So this would need like a better central management system. And this is something that we are currently also constantly looking at and hoping to put these kind of features in a new aggregation server, which would be a natural place where to also manage all of this. And we're trying to understand how the IT looks at the security and how the OT looks at the security. And this is not always such a clear situation in the factory situations. But the aggregation server is actually a very good place also to apply information modeling over like low-level models that the device and machines define. And this will enable like the higher-level semantics, like the PADIM that Sebastian mentioned, to the higher-level applications that are not interested in the tiny details, but they want to have the like a bigger picture through the higher-level information models. We can connect to several data sources and we can combine data from different places, but create like a coherent view to the overall picture. We can do protocol conversions, and there are already a lot of products that are doing that. But in this presentation, I'm assuming that everything is already converted to OPC UA to make the picture a little simpler. Sebastian defined examples how you can convert different legacy protocols, and we have a lot of products for doing that, so that shouldn't be a problem today in general. But what is kind of missing is how can you do this model transformation so you get from the lower level models to the higher level models. So let's take a closer look at the Brownfield device control. How does it really happen today or traditionally? We can talk about process or machine control, and it typically happens just in a PLC. It can happen on a SCADA application. Some machines have SCADA systems built in them, or it can happen in a larger DCS system. In this simplified example, I'm just assuming that we have a PLC that is controlling a mixer. And this is based on the PLC program where we have very basic tags, and the tags are created by a programmer who just wants to like make the control happen, and he knows what these parameters mean. We can probably guess and understand what the parameters mean, but the knowledge is required from the documentation or from the original developer to really understand this. And actually, if we think about the DCS situation, Jocelyn Vallet described this from the viewpoint of PMI on Monday, that in practice you can have tens of thousands of tag names in the DCS system or in the overall control, that nobody really knows which is which. So this is the reality. And today we can convert these PLC information models to OPC UA servers, but that typically just maps the tags one-to-one to the OPC UA server. Another question is that it? Well, OPC UA Part 3 defines data modeling concepts that help taking us a bit higher level. The first thing is that OPC UA defines a lot of different data types, all the basic data types, but you can also define your custom structure types, your custom enumerations, and so on. So we could, as the first step, just improve the understanding of the measurements. We could rename the variables, but we could also introduce enumeration variable that combines information from a couple of bit information, although they're bytes, but in practice they are just on-off information. We have probably the system running or the mixer running, or there's an error situation, and we can combine that to a state. But at the same time, we can also just convert the actual value as it probably is to the speed, and set point to set point to make it easier understandable. So this is the first level. But OPC UA also enables us to create structures. So we can define that this is actually the mixer 1. Instead of just calling it M1, we now know that, okay, it's actually the mixer 1 that we have there in the process. And the next step OPC UA enables is to classify all the mixers and define them the same way. We can make a mixer type and tell that all the mixers have these parameters, and then we can use more or less intelligent measures to apply different logic to all kinds of mixers in the production plant. We could, for example, just prepare user interfaces that are applied on any mixers, and then if we bring a new mixer in the production, you can already have the same model and use that in all the user interfaces automatically. The next level, if we move on to part 4, it defines different services, and these read-write data chains is something that all OPC servers in general support, so we can already read these values of the variables. But then we have the concept of method calls, and most OPC servers or legacy servers don't support method calls, and there is no such a concept in PLCs in general, although the new IEC 61131 mapping for OPC, for example, defines method calls also in the PLCs, and there is, for the modern PLCs, you can use methods in the PLCs, and that's very powerful tool already, like to make the PLCs communicate with each other over method calls. But for legacy, you can't assume that method calls are available. Another concept is events. When the mixer is ready, we would like to just give a notification that now the production has finished, and this was the overall time and average speed that the mixer was running on. But also most OPC servers don't still support events, and the PLCs don't have the concept of an event in general. And these are the bottlenecks why we can't like take these take the full power of the information models, because it's not such easy way to add these functionalities to the legacy systems. Another thing is that most devices don't really have the capacity for history, especially for long-term history. So also this powerful feature is not always available. So what can we do? Well, in this aggregation server, we could easily handle methods coming from higher level OPC clients and just basically map those method arguments to underlying tags, and therefore like introduce a method interface, even though the original data source doesn't have such. So we could basically make a call to start the mixer with speed and time and get the result how that start actually succeeded, or anything else that makes more sense. Or when the information models, high-level models especially, introduce methods, then you would need to have tools to implement these. A similar thing with events. We could have an event generator that just monitors tag information from the data sources and converts that to events. There can be some triggering tags, and then input data to the events. So we could just generate an event when the mixer is ready, instead of the client having to monitor the bit that tells when the monitoring is on, or when the mixer state changes from on to off, for example. Then part 8, the data access actually defines mainly the engineering units and ranges for variables. So instead of just defining that we have simple variables that are of double type, we should actually use analog unit range type or the other analog item types that the OPC defines. This one makes engineering units and EU range compulsory. And now we could extend that also these variables should have the engineering units and EU range. But of course, this information doesn't come from the PLC necessarily. So then you would need to have a way to just attach this information from some external source, or just add the units manually. But this would help the client applications also to understand more about the data that is in the underlying system. And this is the basic idea of the first level information modeling in OPC. Then we could continue to the part 9, alarms and conditions. Alarms are basically, and conditions, events with state. So we can define alarm limits. We could monitor the value that is being monitored and compare it against the limits, and then trigger events. I'm not really going deeper in this, but it would be quite straightforward to follow this path. And part 10 defines the program model, which is more or less like long-running operations. So it's a combination of defining state machines for the system. So the mixer could be in executing state or in offline state or in an error state. Like Heiko Hadden described the machinery model yesterday, which is defining also this kind of states for devices. And then there are methods that change the state of the machine and events that notify the change. So we already described how we could implement the methods and events in the aggregation server, and therefore the program model could be also like basically implemented there. History is another thing that that in an aggregation server you have much more capacity. It's more there's more space to store all the history of all the data sources, maybe even put it in a database behind and then serve the history from the database, for example. Then if we move on to part 14, the new PubSub model, we have two alternatives, the MQTT and UDP communication there. But basically, they're both defining a similar model that defines how you can send data changes and events through a channel that doesn't hold a connection all the time. Randy was describing the MQTT improvements on Tuesday, and but this is already like the existing model where we basically have tags or variables sent out whenever they change. This is a JSON encoding message, so it's easy to read. And now we can just map our variables to the PubSub communication. And of course, in the aggregation server, again, you can just like monitor these values from any underlying UA server and then convert it to MQTT messages like this. So that's pretty straightforward. Moving on to part 100 devices. The model is basically defining vendor nameplate that can be implemented. So we could extend our mixer type that it derives from device type, or it could just implement the vendor nameplate interface as the model defines. And that brings us the manufacturer, device, and serial number information, for example, that could be useful in the higher level system. But this information is typically not defined in the PLC, so we have to add it somewhere else. And also device model defines the device health that could be used for condition monitoring if all the devices would provide this. These models or uses the NAMUR NE 107 model for the device health. And but of course, then this information needs to come from somewhere. So we could just have a constant mapping for the nameplate information. The device health is of course a good question that what kind of logic do you need to really monitor that? But there are a lot of condition monitoring applications that have been defined in the field. It's an anecdote. I could say that I was defining one 20 years ago, and we had to define a complete model for custom model for modeling all kinds of devices to get the health information. OPC would have been a great tool already back then, but now it's available. Moving on to the companion specifications, then we really get to the high-level ideas that we could bring the information models in the model transformer, which sits in the aggregation server, and there we can basically like remodel any custom information models being used in the actual devices. Like in the pictures, we can take any robot model and convert it to a standard robot model. And then in the high-level systems, you don't need to know the differences between the implementations in different manufacturer models, but you could just use the standard model on top of that. And said we have already like over 100 different company specifications for different domains, and that is growing all the time, the number of them. So we really need better tools to take advantage of those. And everybody can create their custom models. Vendors can have their custom models as necessary, and users can use their custom models. But if you have legacy systems, you need to have tools to also take those in use in practice. So that was the kind of the theory behind it. But the good news is we have now a product that we brought in the market after looking at the market for a long time, and we decided that we need to bring this kind of a product available so that we can move on. And we've already been able to help customers in different use cases. Of course, there is a lot of different kind of things that the industry needs to do with different information that they're dealing with. But we've been, for example, helping with OEE reporting, high-frequency data logging, tracking the completion of production orders within an MES system, and this was especially using the event generator and so on. We've been mapping state information and array elements. So also in my description, it all seemed very straightforward, but often the model transformations, they are not so straightforward. So you have to do all kinds of tricks with the data, split arrays to parts or combine them from somewhere, or do all kinds of scalings and transformations. So this requires all kinds of tweaking. And with the reverse connect, we've been able to help to connect from the IT to the OT securely, even when the actual PLCs or SCADA systems didn't support the reverse connect yet. So that's the good news that we have figured out how to do this, and we're working on those features. We have many of those features that I mentioned already implemented there. I know there are also other products that are doing this these days. So it really seems that now people are trying to use those information models, and they really need these kind of tools in the market. So with that, I want to thank you for attention, and if you're interested, please contact us, and we'll be happy to demonstrate how our solution works in detail with all these aspects.